If we're going to use completing the square to solve quadratics, we're going to basically be following this three-step method. So here in example 2 it says we want to solve the equation y equals x squared minus 10x plus 3. Now before you decide if you're going to use completing the square, I would always encourage you to look and see if you can factor your equation, because factoring is obviously a much quicker method. But here the factors of 3 will not get you 10, so we know we can't factor, so we're going to go ahead and use the completing the square. And in order to do that, we first need to set our equation to 0. So that's going to be step number 1. So we're going to have 0 is equal to x squared minus 10x plus 3. And the reason I'm making the y the 0 is because when I'm solving for x, we're looking on the x-axis, and that's where the y's will always equal 0. Okay, so that's step 1. Step 2 is going to be to complete the square, and if you remember from the last video, in order to complete the square we have to move our c value over to the other side. So when I do that, I have negative 3 equals x squared minus 10x, and then I have to go ahead and calculate my b value. So I'm going to take my b value, so negative 10 divided by 2, which gets us negative 5, square that, we get 25. So I'm going to add 25 to both sides. Remember, we have to keep our equation balanced. And when we do that, we get 22 is equal to x squared minus 10x plus 25. Okay, and then remember the last part of completing the square is to factor. The whole point was that we could make it factorable. So we get 22 equals x minus 5 times x minus 5. Remember, these should be matching, and then because they make a perfect square, and we can rewrite that as 22 equals x minus 5 squared. So that is the completing the square process, and then the very last step is to actually solve for x. So to solve for x, what we need to do is get rid of the exponent. So to get rid of a square, we're going to take the square root of both sides. So if I take the square root of 22, if I take the square root of something squared, they cancel out, and I'm left with just x minus 5. And now I can go ahead and I'm going to leave my square root alone, and I'm going to add 5 to both sides. So if I add 5, these cancel, and I'm left with x is equal to 5, and then plus or minus the square root of 22. And the reason I do a plus or minus there is because when you take the square root of a number, you technically get two answers, a positive square root of 22 and a negative square root of 22. And now this would be my final answer. If it asks for the decimal answer, obviously you could type this in a calculator, do 5 plus square root of 22 and 5 minus the square root of 22. But for an exact answer, I would go ahead and leave it in its radical form. So 3 main steps: set the equation equal to 0, do your completing the square process, which we did in the last example, and then finally solve for x. If you have any questions over those examples, let me know. It's going to be the same 3 steps pretty much each time. I would encourage you to try this example on your own, following those same 3 steps, solving y equals x squared plus 8x minus 11. So remember, take the y out and put a 0 in, move your c value over and complete the square, and then at the end solve for x. And if you'd like me to check that in class, I would be glad to do so. Now our last example is when we have an a value that is not equal to 1, because in order to complete the square, you always have to have your a value be a 1. So here we have 2x squared plus 4x minus 5. Because our a value is not 1, we have to do some extra steps before we can actually complete the square. So what we're going to do is go ahead and start with our same step by moving c to the other side. So I'm going to add 5 over to the left. So we'd have y plus 5 equals 2x squared plus 4x. But then this step, where it says factor out the a value, is going to be the new step. Because we have a number here in front of x squared, we're going to factor that out. If I factor out the 2, we're left with x squared plus 2x. And the y plus 5 still on the other side. And now we can go ahead and complete the square. Now when you're completing the square here, you're going to be using this b value. So 2 divided by 2 is 1. and 1 squared is 1. So I'm going to put a plus 1 here. However, this is why I put little stars here next to this step. Because we're trying to keep the equation balanced, technically, if I were to distribute this 2 all the way through, I would actually have a 2 on the right side. So that means we have to add a 2 to this side. Instead of just doing plus 1 and plus 1, you have to take this number in front times the number you add. So 2 times 1 is 2, so we add 2 to the other side. And this will keep both the left and right side balanced in our equation. And then the rest of the steps are just like we've always done. So I would have y plus 7 equals 2 times, if I factor x squared plus 2x plus 1, I get x plus 1 times x plus 1. Rewrite that. We get 2 times x plus 1 all squared. And then if I'm just converting it into vertex form, then I would subtract the 7 over to the other side. And we'd be done. And then I could say that my vertex would be at the point -1, -7. So notice that the 2 in front that we factored out has to stay there. You don't want to divide it out because that 2 makes a difference when you're graphing, because every number would be ending up getting enlarged by a factor of 2. So very important because it talks about the dilation. So never just divide it out and get rid of it, because it would be important in your graphs and when you're solving. Okay? So always factor out the a value after you move c over to the other side. And then just make sure you keep your equations balanced like I did with the green. Okay? If you have any questions about those examples, let me know. But 2 solid examples on completing the square, and that's it for today.